Yes.
Good evening, everyone. I hope I'm audible to everyone properly.
Yes, ma'am.
Great. Okay, sir. Thank you. Let's start the session. Greetings for the day, everyone. I am Professor Manila Gupta with my co-host, Professor Ramya, and it gives us a great pleasure to welcome you all to the inauguration of the ATAL Faculty Development Program on the future of AI and ML, balancing innovation, ethics, and industry needs, organized by the Computer Engineering Department of Rizvi College of Engineering, and it is sponsored by AICTE. At the outset, I extend my respectful greetings to our dignitaries, Chief Patron Honorable Dr. Akhtar Hassan Rizvi Sir, President of Rizvi Education Society, Patron Honorable Advocate Mrs. Rubina Akhtar Hassan Rizvi Ma'am, Director of Rizvi Education Society, Coordinator, our beloved Principal Ma'am, Dr. Varsha Shah Ma'am, Co-Coordinator Professor Shivu Sir, our respected Dean of Academics, Head of the Department of Computer Engineering, Professor Mohammed Junaid Sir. We are deeply grateful to the management of Rizvi College of Engineering for their constant encouragement and to the AICTE for providing us this wonderful platform through ATAL FDPs. Before moving forward, I would like to share a little bit about our college. Rizvi College of Engineering was established in year 1998 in Bandra, Mumbai, is approved by AICTE, affiliated with University of Mumbai, and accredited by NBA. The college offers programs in mechanical, civil, electronics and computer, and artificial intelligence and data science, and is recognized for its modern infrastructure and strong industry connect. The Department of Computer Engineering was set up in year 2008, is NB accredited, and focuses on key areas such as artificial intelligence, machine learning, and cloud computing. With well-equipped labs, research-driven academics, and active participation in hackathons and conventions, the department nurtures industry-ready professionals. The department is guided under the leadership of Professor Mohammed Junaid Sir, head of our department, and Professor Ramya, coordinator, with various experienced faculties ensuring academic excellence, innovation, and holistic student development. Now, I would like to call Professor Ramya to take over and welcome our speakers, guests, participants, and organizing committee. Over to you, Ramya, ma'am.
Thank you, Manila ma'am. Hope I'm audible.
Yes, ma'am, you are.
Thank you, ma'am. Hello, everyone. I'm Professor Ramya Prabhakaran. I'm extremely privileged to welcome everyone on behalf of Computer Engineering Department of Rizvi College of Engineering. I extend a warm welcome to eminent speakers for today, Professor Pranab Lapsiwala and Mr. Pranav Nerulkar. I also welcome our distinguished faculty participants from across the country and the organizing committee. So a word about our organizing committee. The team includes Dr. Anupam Chaudhary, Dean of R&D, Professor Narges Sheikh, Dean Administration and HOD of ECS Department, Professor Junaid Mandiwala, Dean of Student Welfare and HOD AIDS, Professor Dhanashree Kangane, IQAC Coordinator and Coordinator of ECS. We have Professor Kashif Sheikh, HOD Mechanical Engineering, Professor Selvaraj, HOD of Civil Engineering, and we have Professor Jugal Jagtap, HOD of Humanities. I warmly welcome everyone. I welcome our respected Principal Ma'am, Dr. Varsha Shah, our deans, heads, and coordinators of various departments, and all the faculties present here. We sincerely thank management of Rizvi College of Engineering and AICTE for their continuous support and encouragement, which has made this FDP possible. Now, I request our respected principal, Dr. Varsha Shah, to kindly address the gathering and share her words of encouragement. Over to you, ma'am.
Good evening, all. I hope I'm audible.
Yes, ma'am.
Okay. Good evening, everybody. Respected dignitaries of AICT ATAL Academy, esteemed resource persons, industry experts, my dear faculty colleagues, participants from across the country, and our beloved students if they have joined. On behalf of Risvi College of Engineering, I extend a warm welcome to each one of you to this faculty development program on future of artificial intelligence and machine learning, balancing innovation, ethics, and industry needs. We are truly privileged to host this FDP under the aegis of ATAL Academy, a platform that has been instrumental in nurturing a culture of advanced learning and innovation amongst the faculty members across India. Artificial intelligence and machine learning are no longer just futuristic terms. They are shaping the present from healthcare and education to banking, governance, and even the way we communicate. Yet, along with this immense potential comes a profound responsibility. The question is not just what can AI do, but what should AI do? The FDP aims to open a dialogue on three essential pillars: innovation, how can we encourage cutting edge research, novel algorithms, and real world applications that solve pressing human problems. Second is ethics. How do we ensure that our innovations respect privacy, fairness, inclusivity, and human dignity? We cannot afford to create intelligent systems that amplify bias or erode trust. Third point is industry needs, which we'll be focusing on. How can academia align its research and training with the ever evolving requirements of industries so that our students and researchers remain future ready and contribute meaningfully to India's growth? At Rizvi College of Engineering, we believe education must bridge knowledge with responsibility. AI and ML are not just technical skills, they are tools of transformation, and transformation must always be guided by strong ethical foundations. The faculty development program is one of the wonderful opportunities for all of us to engage, learn, and reflect. The sessions planned will not only deepen our technical expertise, but also sharpen our understanding of the socialite and industrial context in which these technologies thrive. I thank my management, President Dr. Akhtar Hassan Rizvi sir, and Director Advocate Ms. Rubina Akhtar Hassan Rizvi madam for encouraging us for holding such events from time to time and making sure that we are at par with the industry. I urge all the participants to take this platform as a chance to collaborate across disciplines, question existing paradigms, and co-create a vision of AI and ML that truly benefits humanity. I also want to extend my welcome for all our further FDPs of the academic year 2025-26, as we have already promised. Whether the further FDPs are ATAL FDPs or self-financed, all the participants of this FDP will be invited and will be allowed to participate in the future FDPs of 2025-26 academic year free of cost. On this note, I extend my gratitude to AICT ATAL Academy for their constant support, to our expert speakers for bringing in their valuable insights, and to organizing team at Rizvi College of Engineering, who are tirelessly working to make sure that this event becomes successful. Let's embark on this journey with enthusiasm, open minds, and shared commitment to shaping a future where technology and humanity move forward hand in hand. Thank you all. I wish the FDP a great success.
Thank you so much, ma'am. Thank you for your kind words. Madam, with your permission, we shall now begin with the technical session of the FDP.
Please proceed.
Thank you, ma'am. So our first speaker for the day, our first session is Introduction to Artificial Intelligence and Machine Learning, Unsupervised Learning and Clustering. It gives me great pleasure to introduce our speaker, Professor Pranav Lapsiwala, Associate Professor at Sarva Janik University, Surat, Gujarat. It's an honor to introduce Dr. Pranab Lapsiwala, an eminent academician, researcher, and consultant with over 19 years of experience in electronics, ICT, RF microwave, and optical technology, data science, and AI/ML applications. Dr. Lapsiwala completed his PhD from Sant Tukadoji Maharaj, Nagpur University, his master's in telecommunication networks from University of Technology, Sydney, Australia, and his bachelor's in electronics and communication engineering from South Gujarat University. He is currently an associate professor at Sarva College of Engineering and Technology, Surat, where he played a pivotal role in academics, research, and innovation. He has guided several PhD, PG, and UG students, served as an examiner and reviewer for reputed universities, and actively contributed to NBA accreditation and academic quality enhancement. Dr. Lapsiwala research excellence is reflected in 34 plus publications in Scopus and UGC listed journals. His contribution to internal conference in Singapore, Malaysia, and Sydney, and his patent granted in 2023 in area of optical communication. His research interests span wireless sensor networks, Industry 4.0 applications, perovskite solar cells, IoT, and artificial intelligence. He has delivered over 25 expert talks, FDP sessions, and workshops across India, and successfully organized national and state level competitions, hackathon, and innovation-driven events. He has also been actively associated with Student Startup and Innovation Policy, SSIP, nurturing a culture of innovation and entrepreneurship among students. Beyond teaching and research, Dr. Lapsiwala has also worked on consultancy projects, including government-funded initiatives, and has been recognized for his leadership in professional societies like ISTE and IEEE. With this blend of academic rigor, research contribution, and industry insights, Dr. Lapsiwala continues to inspire students, researchers, and professionals alike. We're truly honored to have him with us today to set the stage for this FDP with his expertise and insights. All the faculties, please join me in welcoming Dr. Pranav.
Thank you so much, ma'am, for your wonderful words.
Thank you so much, sir. We welcome you here.
Yeah, thank you. Shall we start, ma'am?
Yes, sir. Yes. Over to you, sir. You can
Yeah.
proceed.
I have to share my screen. Yeah. Can I get your sharing the screen? Okay,
So at the bottom, there
Yeah.
must be a share
yeah,
icon.
yeah. I got it.
Yeah.
Is it visible?
Yes, sir. Yes.
Screen is visible to all?
Yes,
Okay.
Yes, sir.
Oh, we shall start now. Okay, so I hope the screen is visible to everyone and I am audible to everyone.
Yes, sir.
Yes, sir. Yes, sir.
Okay. Good evening to
Yeah.
all. And we are about to start with the FDP on the AI and ML. The future of AI ML, that is, everyone believes now and everyone work towards those things. Every institutions, even organizations, companies work one or two way and try to accommodate the techniques, fundamentals, or any new innovations towards the ML and DL. So we start with our own profession. So this is the, how many of you are believing that this kind of classrooms are no longer are in our, we are waiting for this thing. In many European countries, even USAs, they starting this kind of classrooms where the interactive dashboards are available. Your screens are available with the interactions and a lot of informations around that. Lot of sensors and the data are plot on those ones. So that are the futuristic classrooms and the universities, which are no longer be far away from the current scenario. We can hope that shall be the available in a 2030 in the Indias also. And many modern schools having such kind of activities already started. So we are not no longer over there. Then those who are the younger kids, even those who are the uh, young generation people, they having the sensor datas and all. Their interactive halls and the classrooms and everything. Even their walls and the glasses are the interactive. Lot of informations are there. They are AI based, AI enabled drawing halls, even bedrooms, even classrooms are there where people can sense. And based on that, the informations and all these things are available. The base, some things are already we experience, that is Alexa, series, all kind of things are the day-to-day life. People are using those things. Home automations are again be available at our places and all. So everyone is going towards the AI and all. So the first question arises, what is AI or what is artificial intelligence? So it's a field of computer science that focus on creating machine or software that can perform tasks that usually require human intelligence. That is what people are believe. That is what people having the dictionary meaning, definitions, what we can come across. That is a software. But now the software is no longer with the doing a task, but it can be penetrate towards the entire field. Okay, commerce, healthcare, your industries, everywhere. So those are the AI where the human intelligence are the accommodate into the machines and machine act like a human. AI is when machine think and act like a humans, learning from experience, making decisions. So these are the two basic properties which we can face. The experience, we learn from the experience, and the people can make a decisions. Okay, so that was a lagging in a previous or a conventional computing or conventional programming. So they do not having any experience like a human. Even we do having the robot, that is they also having the emotions. So these are the things where we are reaching now. Before we start our journey, so what are the evolutions of AI? So AI is not a new word, but it is since started from the 1950, and from 1950 to 1980, they having the some ups and downs, a roller coaster. But after 1980, 1985, the speeds are started, and that we can consider. So in a 1950, the turning test, the first paper was published in a conference. Okay, so that was a first thing that one has to be understand. That was a paper in a computing machinery and intelligence conference was there, and that exhibits the paper. The turning test is a paper which exhibit how the machine can explicitly behave like a human. So that is the first pioneer, and the Allen was the first pioneer for the this concept of AI. 1956, the term artificial intelligence is coined at the conference by John McCarthy and others. They have a work and they can start working towards those ones. So again, the early conventional system is a rule-based reasoning system. They having the sequence are there. The rules are written and based on the some actions and tasks can be taken care of. The second is one second area is nothing but 1970 to 1980s. And again, the best peoples are the Stanford, and they have contributed mycin. The mycin is one of the software that is developed by the Stanford people for diagnosis the bacterial infection and and recommended by their recommended antibiotics. Now, where the AIs come over there, so that antibiotic dose is depends on the patient's weight, and based on that they can given, and the AI system was launched in 1970 by the Stanford people, and they start working over there. But still, due to the limitation of the computed power and all, so still people are facing the limitations in AI strength. After 1980s, the revival and the second AI winter was started. And over there, we having the knowledge engineering is another concepts are there. So people still 1956 to 1970s, 1980s, people are struggling to find out the funds and the resources to development in AI. And after 90s, again, people having they get some of the computational and the people are industries understand the strength of the AI. They starting the funds and everything, but that is again be very limited due to the limitation of hardware, because we do not having the very powerful hardware which can process AI concept very efficiently. So these are the thing. Then we do having the machine learning era is started, and that is nothing but the data driven chip. So conventional logic driven to data driven chips are coming. So learn from data instead of explicit programming. So that is the people are just saying that we can, so initial programming, conventional programming is nothing but the human like a step by step steps instructions, that is rule conditions and the logic to do the some programming. Let's say we just understand if I want to develop a calculate, so human are liking how to add, how to subtract, how to multiply, division and all, and that is all by the rules and logics, and based on that my entire things are there. But when we having the data, so people are feeding the data, computer understand the patterns and recognition, and then the new era of the computing and the programming is started. And that is a fundamental goal of the machine learning, that is they learn from the data instead of explicit programming. And people starting that era is nothing but 90s to 2000, that is a rise of ML, subset of AI that is focused on statistical learning. So maths, patterns, and the all things are coming into the probability forms and all. So people are behaving like those. Then we do having the certain very drones, algorithm, decision tree, support vector, machine classifiers, and then Bayesian network. And more people are believing more data, better hardware that enables the practical applications, and a lot of advancement and a lot of new applications, lot of new directions, innovations happens in this era. And that is the industry 3.0 where the computing era is started. So we can correlate those things. Then there is a era of deep learning. So again, model complex pattern using the layered neural network. So that is a new era where the all the things happens. And the era is nothing but the 2006 to 2012. That era is called as a deep learning era. The Geoffrey Hinton revised the deep neural network, and uh, everyone knows in a current days, Geoffrey Hinton is again be known as the godfather of the machine learning and deep learning. And he is a pioneer who can provide the certain algorithms in unsupervised learning and all. Then he was a in a team member in a AlexNet, which can in the 2012 ImageNet combination, okay, where they provide the lot many layers programming to identify the image recognition and give the new direction in a computer vision. So Geoffrey Hinton, then Alex are the team members for the their code, which is popularly known as AlexNet for the competition, ImageNet, that is worldwide organized every year. And in a 2012, they developed the CNN's very good image programming that can give the direction to the computer vision. Then we do having the neural era, that is neural network era, that is deep learning. And 2012 to 2020, that is the explosion of DL, where the CNNs, RNN, LSTMs, lot many neural language network where so many hidden layers are there, and we are adjusting the weights and all. So that kind of era is developed and people are doing. Suddenly there is a paper is coming, attention is all of you, and you having the large language model is coming. That is what we are knowing as a OpenAI or a GPT bird and all. The I hope everyone heard about the attention is all of you. It is a paper written by the Vaswani in a 2017, and they are focused on the another approach, okay, for the new deep learning. So the approach was they are not focusing on the part. The next part is already focused by the current part, and that kind of concept can be used in a GPT, BERT, Llama, and all. And that is a new kind of evolutions occur in a deep learning. So we do having the generative AI after 2010 we onwards, and there is a large language model GPT-3, GPT-4, and currently we do having the GPT-5, Claude, Gemini, whatnot. Everything is available, and they are basically work towards the transformer algorithm. The transformer algorithm having the philosophy that they focus on the part, current part is focus on the next part, and that what we observe in a GPT also. So my text word can be considered, current text and word considered for the next query, and that based on that my answers are coming. So that what attention is all of AI, what it is told about. So that lead us to the multimodal AI. So we do having the vision, text, and audio. That is a new trends, and the currently many researchers, many institute, many organizations work towards there. Age AI, responsible AI, AI safety, and generative AI. So I am just quick getting the response. How many of you aware about this word age AI, responsible AI, AI safety, general AI? Just mention few things in a text board so I can access who are the thing. So in a age AI, the edge devices, rather we are going for a centralized uh, working, okay, centralized cloud which can be processed and all, instead of we do having the very smart devices are available which can working on a AI. Okay, so that is a edge devices. The examples are the smart watches and the smartphones are there. Responsible AI are the kindly told about the fairness and the ethicals about the AI. They are not biased for the pertaining groups and the philosophies and idea. And that could be the key things currently people are focusing on. That models are not harm and hurt the certain community groups and all. Safety, again, how my AI can not be harm the particular uh, community or the human or the any other thing while creating something better. And general AI, it is much better than the this all this thing, and they are helpful for the welfare of the human being. Now we having the uh, these things that I already told you about. That is what AI, and every should those who are the machine learning, deep learning AI students, or they are start working towards that. They should understand this thing very well. Where to use, how to use, what kind of ethical things they have to understand and all, and how one can improve their AI system for the benefit for the human being and all. So those are the meanings and the focusing area where the these four terms are going towards AI. Now these are the summaries are there. How these things are there. There are so many new words are there, that is narrow AI and all. So narrow AI is nothing but the why I'm saying this thing, because while people are referring the certain text, certain material, so they having the narrow and the general AI is very big terms, and they are using those things. So narrow AI is nothing but the specific task that can be used for the image recognition or the language handle. Let's say I can just classify cat and the cow kind of image. So that comes into the narrow AI. Okay. And the general AI is a wide variety of tasks without being explicitly programmed for each. Okay, so that are the things. Large language models are the based on those ones. Now, what AI can be do? AI can do and capabilities of the AI. AI having the very huge very large capacity. What human can think that AI can do. So the learning from the data or patterns, they having the key thing, which one is a reasoning, and that was not be found in a conventional programming. Perception, that is recognizing speech, image, or faces. Language understanding, chatbots, and the translation are the examples. Decision making, that is another key features or a key capacity which changing the entire world or changing the entire dimension of the industry. Okay, so the self-driving cars, recommendation systems, and everything. So those are the key things where the AIs are, where the conventional programmings or the conventional things are facing the limitations. So examples of AI in action currently, that is Siri, Alexa, Google Assistant, understanding and answering the questions that we are already experienced those things. Then recommendation by Netflix and YouTube, what kind of searching I am doing, that kind of program they can thrown towards me. Google Maps predicting the traffic, that is everyone using currently. And then the Tesla Cyberboard, that is self-driving cars and the lidars and autonomous missiles and everything. So lot of advancement is occur, lot of things are going to be there, and now we are in the era of drones also. So where we can say that the self-driving drones, autonomous drones, which can be worked towards for the defense also and the commercial also. Now, so now we are come across the definition of as by the academic. So artificial intelligence is the simulation of intelligence in the machines that are program and learn. These are the key thing where the people are working. Now I use the word that is a learn. So what is learning? So to learn the means to acquire knowledge, to gain knowledge or understanding of something through experience it or through learning about it. So those are the two things. I experience something and I learn. So my some kids are crawling and they try to learn the how to stand, how to protect them while they are fall down, how to uh, put the first step and all. So by experience and by learning, they can start walking, they can start running and do their activities and everything. Similarly, with lot of data in organized, unorganized manner, okay, my system is start identifying the patterns. They can start learn from those patterns and use that patterns in a decision making activities. So that is a learning by learning. That is my key things in a modernized artificial systems. To gain experience with something, learn new skills or master a talent, or memorize, acquire something through a experience, example, or practice of doing so. Then the first thing is coming, that is what is machine learning. The machine learning is a methodology for automatically improving computer system through the process of developing using experience and implementing the learning process. So we can automatically improve computer systems, and you automatically improve computer system by fetching lot of data, and from that data it can learn. Then what are the goal of the machine learning? So actually basically the okay, goal of machine. The main goal of machine learning is to able to analyze and adapt data on its own and make decision based on calculations and analyze. As I said previously, we do having the conventionally we do having the rules. We based on that rules we fetch the data. But now I am fetching the data, and my from data my systems are learning and take the decisions. Machine learning is a way to try to improve computers by imitate how the human brain learns. Computer does not have intelligence, it's just a machine for processing. Don't have AI or ML, just data processing unit that use the information they are given. So real-time GPS data is used by maps on a device to show the quickest and fastest route. That what we experience in a Google Map. Google Map shows the fastest routes also, and then they are also give me the traffic intensities and everything. So those are the things, and by those information, we can save our time, even and our energies also. Now, the another word is coming, that is the deep learning, and many researchers and the academicians start, or they are already working on this deep learning. Many theses are working on currently working. They are using this deep learning concept for their uh, applications. So deep learning is a specialized branch of the machine learning that use the artificial neural network inspired by how the human brain works to help computer to learn and make decision from the large amount of data. Now, data is everywhere, and deep learning require lot of data, and they require the large data compared to the machine learning. Machine learning still having the moderate data are sufficient, but for the deep learning we require the large amount of data. Deep learning is a type of machine learning where computer learns to recognize pattern on their own using many layers of processing. So they also learn the patterns by the fetching the data, and for that they having the lot of layers. Now lot of over layers are nothing but what they can adjusting the weights, and by weight they can update their informations, and by doing that they having the some conclusion are coming. So key feature of the deep learning: neural network with the many layers, can handle unstructured data like image, audio, and text, learns features automatically from raw data, no need from manual feature extraction. So from to machine learning, we give the features, but now here it can learn the features automatically from your data. So that is a key difference between the machine learning and deep learning. So example and use cases: image recognition, identify object in photos like cats and dogs. So we do having the lot many labeled data of cats, and then my systems are recognized whether it's a cat or whether it's a dog or whether it's a car. So that is a one of the deep learning things. And speech recognition converts spoken words into text. Google Voice, language translation, power tools like a Google Translate. So it is no longer everyone aware these things. And self-driving cars. Now here on this point, I am just uh, try to differentiate you that if I just want to identify from the images whether it's a male image or a female image, or whether it's a male voice or a female voice, okay, my machine learning can work efficiently because I am giving the features and all, and they can identify whether it's a for a high tone and the uh, high tone and the higher magnitude voice are generally male voices are there. But on the contradictory, the sharp tone and the that sharp frequency, higher frequency tones are the generally for the female tones. But my where my deep learning is coming, if I do having the 100 students in my class and I want to identify which student voice is there, so that time I require the deep learning, and for that I require lot of data which can distinguish the these students from the rest of the students. Okay, so that is a machine learning versus deep learning, and that is what we call them as a machine learning having the feature engineering. So feature engineering is a same kind of thing. Okay, that is having the so feature engineering is nothing but the process of selecting, transforming, creating, preparing input variable. That is the features from raw data to improve the performance of the machine learning model. Where deep learning learn the features automatically. You just fed the any structure, unstructured data, and they learn automatically or they identify the features over here. Now feature engineering is nothing but the we identify the certain variables. We given that variables with the data, and based on that my machine can learn experience, and then they can be help me to take a decision. Over here you just fed the thousand and the thousands of data, okay, labeled unlabeled data, to your neural network with the input as a this raw data information, and my layers are going to be work and adjusting their weights and everything, and then finally I do having the output as a some uh, decision making things. So machine learning having the small data, I give you the example. If I just want to identify the which one is a boy boys and the girl boys from my classroom, so machine learning is a better option for me. But if I want to identify the which boy having or which girl having those boys, so I require the deep learning, and for that I require the large data. Machine learning having the simple model, that is a SVM trees, where the deep learning having the neural networks. Again, by feature, okay, how these three are compared. So definition wise, artificial intelligence is a big pocket of this machine learning and deep learning. The science of making machines smart like humans. That is what people are understand, and the layman people are understand. Where machine learning is a subset of AI, where machine learn from data, and the subset of ML using the neural network to learn, mimic human intelligence, learn pattern from the data, and learn features automatic from the large data. Now, patterns, to learn the patterns, you require the features. Okay, but you learn the intelligence which learns features itself. It's a deep learning. Key function: thinking, reasoning, decision making, learning from experience, learning from complex pattern with the layered models. Okay, techniques: rule-based system, MLDL, algorithm like decision tree, SVM, KNN. Over here, you having the neural network, recursive neural network, transformers. Data required, limited or a symbolic data. Structured data you required, machine learning. Spam filters or recommendation systems, facial recognition, self-driving cars, and chat GPT. Machine learning, the one of the application is my emails, whether it's a spam or not. So I do having the I fed as a template data, I fed as a body data, and then my email systems are trained and they can identify whether this is the spam email or not. Even my messages also like theirs. So now question is, all right, the machine and the deep learning can do so many things, but why we can study and why student can study? That is the one of the question my family members used to ask me, and that's why this slide was here. They are used to ask me why one can only study machine learning. So it is not like what I feel. It is based on the data, what the things are going on surrounding. Studying machine learning is a very well for several reasons, depending on the learner's backgrounds, goals, and interests. And everyone wants to be uh, require the better better lifestyle for their upcoming life. And for that, machine learning is a one of the tool which can improve those things also. So world is changed very quickly. People learn lot many things from surroundings and all. So unequity in a modern world, powerful problem solving tools. Lot of people are using AI tools for their day-to-day life, email writing, their image or videos or reels making. Okay, YouTuber having the content writing, everything they can use, and everything they are doing by the some AI tools. High demand in job market, people require the uh, engineers or the developers who having the AI development skills. Scientific discovery, that is healthcare, foundation for AI and the critical thinking. Now search engine, that is Google, Bing, social media feeds, voice assistant, these all are coming in the Google. Lot of things are there, recommendation system, yeah, Netflix and Spotify. Okay, lot many other things are there. I come across one of the gym training systems also, which can, based on my training exercise, body gesture, they can suggest what kind of exercise I need for. Then powerful problem solving tools. They are solving many things, that is a spam detection and the fraud detection. Okay, high demand in a job market, finance, the for the market or a country like India, financial technology is the key aspects for the, and that can be achieved by the AI and ML. So algorithmic trading, credit scoring, healthcare diagnosis, drug discovery, retail customer analytics, and manufacturing, predictive maintenance. This all the field where the jobs are there, highly jobs demands are there, high pay scales are there, and they require the skilled person who having the skill to understand data and then the machine. Scientific discovery, that is genome projects, one of the example. Astronomy, the how the my telescope data can find and everything. Then uh, intelligent system like robot, self-driving car, language model. Develop critical thinking, which cannot be a bias and give the fair decision on the data available and all. So why required, what required to study AI, what you require the prerequisite. Okay, so curiosity to learn about data patterns and automations. As I already told my all the students, even my colleagues and everything, in previously it was like something like that, you require the maths proficiency, English proficiency and all. But now the only barrier is if you are not curious or excited about the learning, then you cannot learn. So that is the all about the thing. If you are the curiosity, if you having the enough curiosity to learn about patterns and automation, then you can learn. If you having the target that I can develop certain smart application, you can. uh, if you target that my lifestyles can be improved with the better jobs and everything, then you can do it. And intelligent system, even those who are in a job and they want to save their some administrative work like document writing, email writing, then finding the patterns from the excels or the merged tables and everything, they can use or they can learn the AI tools or AI, some AI techniques which can reduce their work. Now, this is especially for the researchers and the students and the faculty member who can associated with the SSIP or the IIC's kind of activities at their institute. So these data can help them. So forecast from the India for 2025 to 2030 by AI growth. So the Indian AI market projected to jump around $10 billion in 2025 to $50 million by 2030 by with a CAGR of 30%. It is a very high CAGR. And believe me, the markets are changed, jobs are changed, the prices are changing and everything. Cloud simple cloud AI segment alone is forecasted from 4.5 billion in a 2024 to 57 billion by 2030 with the CAGR of 52%. Cloud technologies, edge technology are the key for those accommodation for AI and ML. Key component of the GDP which can contribute by the 400 billion by 2030. The growth opportunity where which sectors can grow. So the one is a healthcare where the drug discovery and the diagnosis by the certain patterns and all we can diagnose. Means uh, there are the food habit, my blood reports and everything, and then they can predict whether the some person having the similar kind of blood reports and they find the heart attack in a 1 or 2 or 3 years. So might be possible those who having the similar kind of things, So doctor can prevent and all. Financial service, fintech, the BlackRock is a one of the example, and Geo Financial uh, having no longer it is available now. Agriculture, precision farming, again there is a geo agriculture is a precision farming. They having the drones, they collect the data set and all, even they forecast the prices of the crops and everything. Predictive maintenance in a manufacturing industry to reduce the downtime and the maintenance time and improving the yield. E-commerce, personalization and the logistics. At this instant, I just saying that in 2024, Pradhan Mantri Narendra Modi ji announced the ULIP, that is a Uniform Logistic Interface Platform for the India, which can be combined all the route of my logistics, railway, air, then shipping, and try to find out the shortest route with the cost and all these things. So that is again be huge market and huge area where the researcher can focus or the industry people can focus. Enterprise AI, customized domain specific platforms. Now there are the startups which are the getting the huge funding from the government and the private sector. So 2,900 AI startup in India with the 1,500 active and growing. Okay, from 2025. Funding reached almost 2.3 billion in 2024 with the and they can increase by 28% year on year ending. The new players like Sarvam AI. I hope this is the first AI large language model like GPT, but and the two people are making this. These two people are working towards this thing. Sarvam, that is, I'm just giving the name. The AI startup and the Sarvam is funded in a 2023. Almost $41 million is given to them. And the two founder members are the Vivek Raghavan and the Pratyush Kumar. They are the founder member of the Sarvam. They can give the help to the government, enterprise, and everyone for that this platform. The NISA is again be a generative AI infra, that is a Bombay-based company which can specifically work for the AI cloud. Okay, so and they are also be funded in a 2013. The founder member is uh, Sharat Changi and the Anidya Das. And so these are the case studies one can work towards that, and there are so many other startups which can be working towards those things. So I encourage, and the information itself motivate the researcher to work towards those ones. Job growth, huge market. India is a potential country where the maximum jobs should be created and the high roles, leadership roles are there. Now, what are the key skills required to be a AI? So programming, framework, algorithms, tools. So one should be understand Python, R, SQL, algorithm, MLDL, all these things. So those are the things. These are the summary. Now we start with we talk lot of about the AI and all. So now uh, before we understand the deep learning and the machine learning models, we understand the data, because when the machines are run, they require the fuels, and both the machine and deep learning, even generative AI or the multimodal AI, everyone require the data. And over here, data is my fuel. So data is the new oil. That is given, that definition is given by kind Humby, and without data, my machine learning or deep learning models cannot be work. So it's a input data that feeds to the model, and based on that data, my model can run. I select the best suited model for my application, and then it is can start it. So over here, I do having the certain thing, that is a quantity, quality, and relevance of the data directly affect the model performance. That one has to be always be remember what amount of quantity, what number of what amount of data I'm feeding, what quality of data I'm feeding, and how they are relevant, how the relevance those data having. if I'm filling the two attributes and they do not having any relevance, okay, so my model cannot predict or my model cannot be work properly. So those are the things. Then ML, there is a label data is used to teach the model. Label data means I do having the attributes that is very fixed attributes, and I am telling those things like there is I do having those models are there, and so I am feeding the cat data. So the shape of the cat, okay, height, weight of the cat, I am feeding those things. Those who are not understand label data, so I am just giving the thing that let's say I just want to identify the apple and the lemon. So I am just saying the color is red and the weight is around 100 gram to 110, 120, and it is in a spherical shape. If I given these three attributes and fed the data, okay, then when I am giving the new images, again they can identify whether it's apple or not. Similar case for the lemon also. So that is what I'm talking about the label data. Label data means you having attribute that is fixed. Then DL, that is a massive data set are required. Millions of images you have to feed and then you can doing so thing. AI system data provide knowledge, context and real world representation. Now data is simply raw information, and that is a what kind of data is. So that is a number, figures, temperature, exam score, text, that is a tweets, email, product views, image, photo from the camera, audio, voice recording, clicks. These all are considering the data and how I can use those data. That is the thing. Then that is the question is another field is coming, that is data science, and that is again be a very useful thing for my machine learning and the deep learning algorithm. To understand the machine learning and deep learning, you must to understand data science, data analysis and data analytics. So engineering plus statistical plus domain knowledge. See, this is the key thing. Domain knowledge is required. Without that, uh, it is very difficult to select the model. Even it is very difficult to select the particular data attributes, okay, to train the model. So these things are there. That's why I written those things. The role is to prepare and transform the data for AI and ML, builds data pipeline for perform feature engineering and ensure model interpretability. Hello? Uh-huh. So those are the things. Okay, I'm just attending the few questions. So, I'm addressing what is AI is a big see that is a AI is a big picture. Okay, AN is a subset of AI, a subset of ML and the DL. Now one can just saying that I do having the very raw data and I'm doing something, but where artificial neural network is a part of the uh, TL, where you having the you feed the huge data, okay, that is in form of the images, in form of the audio, in form of the text, and then my layer can behave adjusting the weight and they can predict they can predict or they can take a decision for the action, where AI is just artificial intelligence system where the things are happens. And I'm going to share my PPT. So those are the things. So data science are there. Data science is a field of focusing on extracting the insight and knowledge from the data. So if you are extracting the information, it is very easy. Then we given them to the programming. and then my machine can learn from those features, and then it can be helped to take decisions and all. Now, data analytics. It is used to identify what happens and why it is happens, and that can answer by the data analytics. So once I given my data to the my machine learning or deep learning algorithms, then I can answer these questions. So it is a data analytics field. Now, uh, these are all are the just for the prerequisite of the understanding of machine learning and all. So as I said, what we require now, as per the term, that is data science, it is a multidisciplinary field that use algorithms, statistics, and machine learn to extract insight and the build predictive models. Okay, the focus is discovery, prediction, and automation. The data analysis is a narrow, and it can just having the focus what happened and why. It can just focusing on the uh, why this happens. Okay, you have to identify from the pattern and try to understand why it is happens. And the data analytics, it's a business oriented approach to analyzing data for decision making. So by using those analysis, we train the model, and then we it will be help me to decision making things. Like, let's say I am giving the one of the factory, okay, where the plant is going on. Okay, and I do having the lot many sensors datas are there. That datas give me the lot of information. Now from reading those data, I can predict whether my there is something wrong is happening or not. It is similar a philosophy, like if human can having human can feel bad or having the fever or a sickness or uneasiness. So before that, he feel having the certain his body temperature is changed, his mood is changed, or something happens in his inside his body. So same thing, I do having lot of data I can measure, and based on that I do the predictive maintenance. So by those analysis, I can start understanding that what will happens, and I can protect my systems also and do the maintenance also. So those are the expectation from the data science, data analysis, and data analytics. So data, that is a raw material and core input from the core input for your core input for training and inference. Data science, it's an end-to-end pipeline and modeling. Design and implement AI ML model using statistical techniques. So a statistical relationship, one has to be understand and the derive mean, median, and everything. And that we can using for my ML models. Data analytics, that is insight generate guides problem selection and the model goals and everything. Now, machine learning, okay, and how these data mining and statistics are there. So it is a combine, they can mine, analyze, and then feed the data to the my models. So function of machine learning to gain understanding of the cyber phenomena that produce the data that being investigated, understanding of the underlying phenomena in front of model, and predict the future values of phenomenon by using model was the just generated. So this is a machine learning cycle, how you can develop the machine learning algorithm, or one can say that how my machine learning algorithm works. So access and load the data. The first task, you require the data. So featured data, then pre-process the data. You having the cleaning or you having the inputting everything. Cleaning means, let's say I am writing the Mumbai. So someone is writing Mum, someone is writing the capital M and MUM, someone writing entire Mumbai. So that will give me the noise in a data. So I can do the clean or make it all in a similar format. Even there are some missing data, so I can use mean, median, kind of things and fill up those things. Derive feature using the pre-processed data that I already told you. Then my task is the finding out the relationship between the my features, and those things I can provide to my model, those features that I provide to my model, with that data, I train my model for the what targeted application or what I'm targeting. Iterate to find the best model and integrate the best trained model to production system. And that is what machine learning cycle is. So what cycle follows: data identification, data preparation, selection of algorithm. This is a key. Now, there are the lot of problems are there, lot of algorithms are there. Which algorithms is fitted for which problem? That is a key thing, and that one has to be learned nowadays. Train algorithm to develop a model, evaluating the model, deploying the model, performing the prediction, and access the prediction. So machine learning can help face and speech recognition, fault detection, automated trading, energy demand, and all. So workflow begins. Now, there are the two main class of the machine learning. That is a supervised learning. So can anyone tell me, everyone heard about this thing. Can anyone tell me what is a supervised learning? Feedback loop. See, uh, feedback loop is what I mean to say that all machine learning is a open loop system. They are not the feedback loop kind of system. Let's say I want to predict the my stock price. I'm giving the example. What is I want to predict my stock price or index price, how my stock price is going to be behave in a near future. So I am feeding certain data and then I am giving those data to my system, my models, and then my model is going to be predict. But they cannot be, but they predict what should be the price or whether what should be the trend is. It is a uptrend or a downtrend. That is what the financial people and the what basic machine learning algorithms are there, and it is an open loop system. But if I am just saying that I want to be draw down my risk also by that prediction, if I want to find out my risk, even I want to be find out my drawdowns, even I want to be find out the how much money I can put on a by on that prediction. So that can be happen with the another models or another system, that is a feedback system. So those are, I hope I am giving the answer of those things. Now supervised learning and the that is a label data. Label data in a supervised learning, the person itself aware what is my output goal. Okay, means I just the developer having already idea what his output goal, and based on that he can select the features, and that features are the label data. And many of you are given the correct answer, so I am happy that this session is interactive and all. Okay, but when I am making the full screen mode of my presentation, so I am not able to see the what I mean to say that what I am not able to see the screen. So yes, algorithm learns from the label data and all, and your label data is nothing but your feature data. Is my PPT is visible?
Yes, sir, it's visible. So, if can I read the questions for you on the chat while
No,
you
no,
are
ma'am.
okay?
After certain time, I can going on a chat room and then answer. Okay, not an issue. And
Okay, okay, sir. Thank you.
finally, we having the question answer session also.
Right.
Okay.
Yes, sir.
Yeah. So supervised learning. So supervised learning is nothing which requires training a model with the data whose input and outputs are already known. Means I already told you in a supervised learning when we are I predict that is a x and y and my z is my output. So I already knowing what is my output and what I want to predict. So based on that, I can select my feature data, that is x and y. and that what we call them as a attributes, and that what we call them as a label data also. And that is a key understanding of the supervised learning. So which requires the training a model with the data whose input and output are already known in order for the model to be able to predict future output, such as whether or not an email is authenticated or spam, or whether or not tumor is cancerous or not. So a lot of informations available for the healthcare sector, the drug discovery and all. So that is coming under the supervised algorithm. Even I can just saying that I have to be put my all the incoming emails in a inbox category or a spam category. So that is a very easy that I can just select the spam features. Now, what are the spam features? That my subject titles and the templates are not be appropriate as a regular emails. So that data I can put into the my attributes, and then I train my model. So whenever new emails are coming into my inbox, they can itself putting them in a spam category, and I do having the some authentic emails are coming over there. Then there is a tumors. A lot many research had happened in a 20 around 2020s, where tumor images are fed to the machine learning algorithm, and by the by machine learning algorithm identify whether the tumor size, their tumor size and everything, and based on those diagnoses they said that it is a cancerous and all these things. Then speech recognition and all. The currently people are working on a credit card fraud. Okay, the numbers they are given, OTPs, and then the lot of financial frauds are happening, and so people are using the machine learning algorithm to identify and recognize those things. On the contradictory, there is another learning, that is unsupervised learning. So as it is opposite to the supervised, I'm not saying the opposite, it is a contradictory. So here you do not require the label data. You having the data, you just fed to those one, and then I do not having any awareness about the my output, but my data, my model can learn from the data, and then they identify certain patterns and make the people my data points in a group, and that is what we understand about the unsupervised learning. So analyze data to uncover previously unknown patterns or structure. So it is used to infer conclusion from the set of data that contains input but not tag answer. The most prevalent method of learning without being observed is a clustering. So everyone knows, academicians having this word is not be a new one. Clustering, everyone come across the word clustering. Exploratory data analysis is used to uncover hidden pattern or ungroup in a data. Application clustering can be used for gene sequence analysis, market research, and object recognition. Now, gene sequence analysis means, let's say I do having the different races people data set X, Y, and Z, and from that I just want to be identify what are the common features from these different races and all. And for that I feed all this data, and certainly I can find out that these are the common features of different races, and they are the group in front of me. Now there are the lot many popular algorithms by the machine learning. Supervised learning, there is a classification, then there is a regression. Unsupervised learning, that is a clustering. So supervised learning classification, you having SVM, discriminant analysis, naive Bayes, nearest neighbor and all. Even Bayesians, naive Bayes are the Bayesian things. So those who are the students of this subject, they should learn this Bayesian's classification or Bayesian theorems and all. Regression, that is a linear regression or logistic regression. SCR, GPR, ensemble methods, decision tree, and neural networks. Okay, now neural networks, when there is a neural networks are coming, that means it's a deep learning thing. Unsupervised learning, you having the clustering, then partition algorithms, K means, K medios, fuzzy C means and all. then hierarchical Gaussian neural networks, hidden Markov models, and lot many unsupervised learning algorithms. Now, the most I used to ask this question to my PhD students. Okay, see that they said that I started work with the SVM classifier, I started work with the regression, I started work with the ANN, I select LSTM, and I used to ask them why you select this thing, and they said that we do having the research paper, and in this research paper they are giving the such kind of information, that is a referral system. So I said, it is okay, I can accept this answer, but what are the your key understanding why you select these features? Means I am asking this question uh, to these people, my colleagues also who are listening currently. Okay, if someone is asking, there are lot many models are there. What are the basic understanding or what are the basic fundamentals which will help you to select the algorithm? I am not uh, asking that your expert is required for this and your expert is required for those and all. But if I am selecting the recreation, then what should be my mindset or logic which can say that I should go with the regression? Data loss, data accuracy. Can you uh, elaborate more on this thing? Data loss or data accuracy? See, there are you are very nearer as per if your answer is related to data. So what I learn, okay, as I am a student of this subject. So what my learning is saying, there are the all the data having their distribution patterns are there, and based on that distribution patterns there is a normal distribution, log normal distribution, Gaussian normal distribution. Okay, and based on that there is a one approach which can help me to select the supervised unsupervised learning. Inside that, what kind of algorithms are there? So that approach is suited for my what kind of data behavior and the data relationships are there, and that's why I introduce those data science, uh, data analysis and data analytics part over there. Because if you understand the data, if you understand the statistics, and if you understand the uh, domain knowledge, that really helps to select your model very quickly, and then you can give the correct data, correct amount of data to train your model, and which can help you to increase your accuracy. Sometimes what happens, whatever data you have, okay, based on that you can create a new data also. That is a creation of new data from your existing data, and that can reduce the your attributes also. Let's say I do having the 5 attributes, but all of those 5 attributes are give me the relationship. Okay, and I develop the some statistical methods, and I develop new attributes and giving fed that attributes to my model. So that give me the better accuracy, reducing my time, even my resources also, to improve my model. And that is what I am trying to learn, or that is what I learned from my experience, especially for the finance data, because I am basically working for the finance and all. Now, why I am saying this thing? 6 months ago, there is a one company in my city. I am not giving you the name. They are the very good company, and they want to develop a predictive models for their business operations. I mean to say that they try to develop business operations, means their daily business operation, and they want to predict. The company was a diamond company. Those who are manufacturing the diamond, means what is their short operations are there. That is, I am just going to tell you. They purchase the uh, raw diamonds. Okay, that is a rock. and then they applying the process and all, and then from that they are getting the polished diamonds and all. They sales and market into the export domain, export also, and inside India also. Now, while they are doing the processing, they having the certain uh, loss in their raw material to finished goods, because by there are the certain loss. Even the diamond prices are depends on the what kind of polishing they are doing, and they are the technical thing. So they call me to develop and develop for us such a system as a consultant. Uh, I am coming on a semi-supervised here. Okay, I am just giving you this thing. So they call me to give me this answer. Uh, how to solve this thing. Now we are the academicians. We learn all the algorithms and everything. And believe me, they give me the Excel file, which having the almost 150 attributes are there. The one of the good things are there. They can maintain their Excels very good. Okay, all the operations data and everything, and they give me the all the fields name also. Okay, what they are for and everything, and uh, we and their teams. Okay, I am the person and their developer teams and all are there, and we have sit together for many sessions. Almost 5 to 7 sessions are there, and we identify the key parameters, and then we go with the predictions and all. So that's why I'm saying to understand the data, then you can go with the models and all. So these are my slide is telling you those things. If need to train a model to produce a forecast, such as the future value of a continuous variable like temperature or a stock price, or a classification serves as a determining what kind of automobile is an webcam footage, go with the supervised learning. Now, again, I'm saying that is a continuous variable. I'm saying so time dependency and time independency. That is again you have to consider, and based on that your model should be selected. If you want to look at the data and train the model to identify appropriate way to represent it internally, for as grouping it, so then go with the unsupervised learning. So there are I am just giving the example. Assume doctors want to determine if someone will suffer from a heart attack in the coming year. So what data it having? So it having the blood data, and then some EEG or EEG data are there. By observing those data, basically EEG data and then the blood report data, it is a multimodal AI. It is an advanced concept. But you just imagine you having the blood report data, and based on that you have to predict. So I require the certain features, and then I can start over there. So the most important data is over there, that is the age, weight, height, and the blood pressure. Okay, these are the data. Even you having the some other data also be required. Okay, I am not coming on those one and the make it complex and all. And from that data, if my things are going to be this my datas are coming near to the new entries. Okay, so they can say that this person having the probability of heart attack in a near future, or near 1 year or a 2 year. So those way one can start working. Then supervised learning, that are the two basic techniques are there. One is a classification and another is a regression. So classification method makes the prediction about discrete outputs, such as whether an email is genuine or spam. So classifier, you use the classifier. Like if your target is such like that, then you use the classification models. That are the thing. So classification model is classifying incoming data into the categories, and that will help you, or that can make your pain somehow relief. Imaging a medical purpose is speech recognition, and the rating a credit are a few example of typical application. Believe me, this one is the most beautiful application, which can give you the recognition also and the money also, financial. Then regression method. Prediction can be made with the regression algorithm about things like shift in a temperature or alternation. Means you can just try you having the output, targeted output that is above or below with your uh, targeting line. Okay, so you go with the regression, or you again want to be in a group way, then you go with the logistic regression also. So the most typical application are stock pricing predicting, as I said, but regression is a very bad tool for the prediction of stock pricing. Then handwriting recognition, it's a good one. Electricity load forecasting, it's again very good application. But the again issue is that is a OT and IT interface, acoustic signal processing and the other similar. Anyone let me know what is OT over here? Can anyone let me say what is a OT? OT is a operational technology data. Now, the issue is if you are going into the industry, generally this grid data, then the load data, transformer data, the data are basically not available. Even we generating the synthesis data, even people having the very too much reluctance to providing those data. But still, I am giving the example. That is a very good example. That is a electric load forecasting. Why I am saying that? uh, India having the very good future. India is working. Many research theses are in a coming days. Upcoming days are working on this thing. The reason behind that, India is targeting green fossil fuel energy, means without fossil fuel energy sources, and those are the solar and the green hydrogen. Now, the issue with the solar, green hydrogen is a very new technology. I'm not talking on those, but solar I'm doing because my one of the PhD students are working. We had awarded those ones, so I am knowing the few things related to those things. So in a solar, the issue with the solar is India is Gujarat, Maharashtra, and some other Rajasthan and Madhya Pradesh. Okay, UP even. These are the countries where we do having a lot of sunlights are there, and you can collect lot of sunlights and the energy and all these things. Now but issue is we do not having the grid structures are there. Okay, means grid structure means I cannot be put in my energy, which is I am collecting in the daytime. Okay, I could not put it into grid because there are no special grids and the special things are there. Or the problem is very simple. If I just generating the 200 kilowatt in a daytime, so there is no system that I can provide the 200 kilowatt on a night time also. So load balancing and the load calculation and the other things related to grid, smart grid and all, these are the very good futuristic research domain. And it is a need of India. It is a need for India also. And government and the government sector doing lot many things, renewable or without fossil fuel energy, and one can apply for that research project over on those domain also. But I already told you, lot of datas are not available. You have to generate the data and then apply the model and predict and all these things and lot many things inside those things. But this was the example I given over here. So uh, that's why I'm talking about what context for this one. Acoustic signal processing, that is marine signals and all, and other tasks. So that are the thing. Then again, supervised learning techniques, that is a classification technique. I already said tag or categorize in a group or classes, regression, collection of data. Then binaries versus multi-class classification. So a single training or a test type item, that is in a two class, a binary and all. Multi-class classification techniques, problem might be separated into more data into two categories and all. So logistic regression, that is when you have to be uh, group and all, that time you can use those one. Uh, Parameter to consider while Wait a minute. I'm just taking a pause. Okay, so parameter to be considering while selection of the machine learning algorithm. So the amount of time spent in a training, that is a most important thing, because we require the high processing and the high power equipment. And memory is a key thing. As your number of input increase, your resources increase in n square. The accuracy with the prediction made the new data and the level of the transparency and the interpretability. Now, these are the, I think it is not be visible, but these are the algorithms for the machine learning. Then popular machine learnings are the Bayesian and clustering. These are again be a very small thing. Why I'm putting this thing? The reason behind that, those who are start learning or those who are working towards the machine learning, deep learning, they should know this kind of thing. Okay, so Bayesian is basically used when the new event has occur and you increase or you can update the current probabilities. Okay, that time you require the Bayesian kind of thing. Okay, so those are the thing. So you said that I am just giving the example. Medical imaging system that look for a sign of lung disease. Okay, now I do having the certain new things are coming. So I update those one and that will help me to improve those things also. Then clustering all are there. That is we can grouping the data points and all. Decision tree is what are the choices are coming. That are the thing. Dimensionality reduction. Now it is another very big topic to talk on. I'm in a brief. I am just saying, as I said, there are the lot of attributes I can give. Let's say, uh, if I want to identify the genes from the races, okay, I my previous example, and I do having the at least 10 attributes are there, 10 attributes, 10 variables are there, 10 columns are there, and then I do having the row data. And if I want to find out the relationship for every row data to another row data, okay, that will be very difficult for me and even machine also to those things. So we can just reduce the that dimension of the attributes and all. And for that, the methods are using is a dimensionality reduction, and the popular algorithm is a PCA, principal component analysis and all. Then instant base are the again be a there is a very frequently it is very random change of data. So we use the instant base algorithm and all, and that happens in a biology and chemistries and all this kind of thing. Now machine learning, deep learning, and the neural networks are there. That is another session. One can talk on those one. Regressions are the two variables are there. Linear regression, one is dependent and independent variable. And we do having the curve fitting curve methods are there. R square, based on the R square, I can put the best fitting line, and based on that, my prediction is work. Then rule-based machine learning algorithm, that is popular one is a reinforcement learning. Now supervised, unsupervised, and semi-supervised learning. We come with the unsupervised learning, but before unsupervised learning, I am going to answer the semi-supervised learning. So semi-supervised learning is a learning where you having the partial amount of labeled data and the huge amount of unlabeled data. And that is a example of the uh, and that is what you can put in a thing like in a medical or a industrial medical imaging or a industrial application where the unsupervised learning or a semi-supervised learnings are playing a crucial role. Okay, so you having the one or two are the label data, one, two, or three are the attributes are the label data, but the rest of the are the unlabeled data. Okay, and then you combine both the things and going for a some thing. Now these are the example, most common or easy example to understand, that is a fraud detection. Okay, so someone is stolen your OTP, or you given the OTP, or you having your few datas are available with your bank account or credit card data, and based on that they having the relationship, but others are not in a relationship or unlabeled data, and the fraud happens. So those are the coming under the category of unsupervised learning. Uh, then industrial, that is manufacturing system. Okay, that is uh, in a defect classification. So you having the motor is there, okay, AC motor is there, induction motor or AC motor is there, and you find out the what kind of defects are there. So that is again be a semi-supervised learnings are there, because there are lot many defects on those kind of problem. You having the sensor datas are coming. So one is a current, then the heating, then eddy current, then so many, and based on that your learnings and all these things are there. So those are the things one can going over there. Now we start with the unsupervised learning, especially in a clustering. So clustering or a cluster analysis is a method for dividing a group of data objects in the subgroup based on a single observation. So you having lot many data points are there, and you fed that in your algorithm. Based on the algorithm techniques, okay, your data points are coming into the groups, and there are the certain methods, statistics methods or maths methods which can doing such a thing. That is only the thing. So in simple terms, the effort of dividing the population into the multiple group, so that data points of one group can easily be compared with the data points of another group. And over here, the data points of the same group having the similar properties or attributes, you can say that. Now, uh, this kind of problem is generally using for the e-commerce customer, those who are purchased on a discount or those who are not purchasing on a discount, those who are purchasing on a weekends, those are who purchase on a weekdays, those who are purchasing the uh, accessories or the groceries from the onlines and all. So those problems are there, and one can learn, and not many datas and the algorithms and the things available on a open source platform also. So I do having these data points are there, and I make two groups. That is what clustering are saying that. Now application of clusterings. So domain where the clustering having the impact, that is a mining of data statistics, okay, and the machine learning. So high income, average income, and low income, that is another class of clustering. I do having the data set which can say that the income, age, and all, and my then from those data they can classify it is a one group having the this data, one group having this, and one group having this, and that is nothing but income data. So it is an example. तो अनलेबल डेटा टू लेबल डेटा उन्होंने फाइन कर दिया. मैंने एक जनरल मेरे सोसाइटी, दैट इज आई एम लिविंग इन माय एरिया वेयर आई डू हैविंग द 1,000 people information, and from that data I applying to the clustering algorithm, so they identify this way also. Then financial service, health information, web mining, that is a good one. That is one can work on this thing. Credit card fraud and the criminal activities, image or text recognition system, and the page search. This is again a very good activity. I do having the PDF, and that I can search by this activity. Types of clustering. So that is again you having the three type. One is a partition based, another one is a hierarchical based, and the third one is a density based. The most popular, that is a partition based clustering. So that is a k-means. So is anyone uh, told me what are the application of k-means, where you heard this word? Anyone let me know? K-means is the most basic problem to start, basic algorithm to start with, where there is a data point and I select the centroid of those data points and all. So those are the key logic to make a cluster over there. So partition algorithm is a one of the applied clustering algorithm. So in that there are so many categories are there: k-means, k-median, fuzzy means and all. This clustering method classifies the information into the multiple group based on the characteristics and the similarities of the data. So I just having the data points, and then based on the similarities and the characteristics, they can classify. In the partitioning method, data set contains multiple and object, then the partitioning approach divide the Haji sir. Okay, divides the data into user specified k partitions, and each represent the cluster and its group. So divided into the k groups. So how many groups and how many groups should be optimized? There is a key things for the k-means clustering algorithm. It divides the data into k groups or partition in a such manner that each group should have at least one object or from the existing data. So that are the thing. To put in another way, it splits the data into the non-overlapping subset or perfectly fit on them. So the algorithms are the k-means, k-medians, and the Clara clustering large application. So then the second one is a hierarchical based clustering. Okay, now here that is a agglomerative clustering. That is a one of the popular algorithm are there. Then diverse divisive clustering algorithm and hierarchical clustering. Now over here that is a agglomerative clustering algorithm work on a bottom up strategy. Now bottom up and the top down is nothing but they can merge and split. So the philosophy for this algorithm is nothing that they consider all the data set as a individual data set, but when they find out these are the uh, similar properties and all, they can start merging, and that merge and all they can start merging with those one. So let's say I do having the data points like this is my data points. So they start finding this is having the similar, but this having the dissimilar properties with me. So they can start merging all these similar data points after every step of iteration, and then suddenly they found the some cluster for those one, and that is nothing but that strategy is coming under the bottom up strategy, or you can say that is a then another one is a top-down strategy. So in a top-down strategy, they split. They assume the philosophy is started with, or a algorithm started with the philosophy, all are the same cluster. And they find the dissimilarity, okay, with the some properties, that is a distance or the means or a medians or a skewed, okay. By those properties, they can split them, and that is a top-down approach. So agglomerative clustering is uh, top bottom up strategy clustering, and they having the very good application in a financial sector. So an algorithm that groups data point with the similar properties that come as a cluster, as already know. Hierarchical cluster is a set of cluster, and these cluster are always be different from each other. Now why it is a hierarchical? So they having the tree kind of approach. Okay, how the my trees are there, their branches and the stems and the leaves and all, and that's why they are using this word. So they having the space complexity. When the number of data point is large, the split the space clustering required for the hierarchical clustering technique is large, since the similarity matrix must be stored in a RAM. The space complexity is measured by order of square of n. So that is one of the limitation also and strength also. Then another one is the time complexity. The main complexity also very high because we have to execute in an iteration and update the restore the similarity matrix in each iterations. Okay. The order of the cube of n is the time complexity. Time complexity is the again how many data points and how you can finding out. You find out the similar and the dissimilar properties. So it consumes lot of time. So hierarchical clustering does not have a mathematical goal. All the methodologies apply for calculating the similarity index between the cluster for every situation. Due to high space and time complexity in clustering algorithm, not applicable for the huge data. Now, density-based algorithm, that is, they just what is the philosophy over here? They just measure the distance with the neighbor data points. If the and that distance is the nothing but the Euclidean distance. Okay. If the two data points distance are minimum, they can accommodate them as a in a cluster. And that is nothing but the philosophy and the methods of the density-based clustering. So cluster are formed in the density depending on the clustering technique based on the density of the data points represented in the data point. Those locations that becomes the dense as a result of large amount of data and points that reside there are the term as a cluster. Now, this kind of approach are generally found in a vehicular ad hoc network, wireless sensor network, IoT and all, where you can predict something, and it is a research-based algorithms. So it starts with a random unvisited starting data point, all points with the distance epsilon classified as a neighboring point. So you just this is my data point, so it can just identify which having the minimum distance from their neighbor. So these all are their neighbor. So these two are the minimum distance, so they can accommodate them in their cluster. Then again, if these clusters are there, they can again find out the distance. If it is higher, they can change it, or otherwise it can accommodate in another neighbor. So how it need a minimum number of points within the neighborhood to start the clustering process. In this scenario, the current point of the data turns into the first point in the cluster, else the point is regarded as the noise. In the either case, the current point becomes a visited point. The points within the distance epsilon becomes the part of the same cluster, and this process is repeated for all newly added data points in the cluster. Continue with the process until you visit and label each point within the epsilon neighborhood of the cluster. On the completion of the process, start again with the new unsupervised point and thereby learning the cluster. So K means I already said that is they having the data point. So randomly they select the centroid and then they find the Euclidean distance between the two data points, and they again find the centroid and then again find the Euclidean distance. Hello? Hello? So this is the most commonly used technique for a K-means. These are the data points and these centroids are together. Okay. These are the, I'm just saying that this is my new centroid and these data points belongs to this centroids. These data points belongs to this one and these data points are no having. And then your clusters are there. Now with the K-means, the assumptions are there. They assume that this many clusters are there, 2 or 3. And based on that, that is a 2 or 3 centroids are there, and based on that, my clustering process are there. Now, what are the optimized clusters? Okay, is required. That is a technique, and that is what the K-means clusterings are worked for. And this is the main curve that what I mean to talk about. We run the clustering algorithm with the different value of K. We maintain the total variance we get in the clustering using the different value of K. we will notice that the K increase, the reduction in the variance also increase, and plot the data on a graph as shown in a figure. So up till here, your data having the variance and all, and then it is suddenly in a saturation point. So for my data point, these three clusters are the optimum cluster for the k-means algorithm. So this way we having the k-means clustering algorithms are there. So difference between the clustering approach, core idea, partition based, that is divide data into the fixed number of cluster, build a nested cluster via merging or splitting, and density, discover the cluster by the dense region separated by the space. Input require more specific number of clusters, no need to predefine cluster points, and require the density parameter epsilon. What minimum distance you require for the clustering. Cluster shape, spherical, equally size, flexible, can capture nested structure, also arbitrary shape. Other handling a poor outliers, these spots. Now moderate and then the strong. That is a scalability. Partition base having the high scalability, hierarchical having the low. If your data points are higher, it is a very bad to select hierarchical, and density again moderate. Interpretability, that is a straightforward centroids. Visual, that is a dendrogram, it is a tree kind of approach. And spatial, that is a density plot. Example, K means K medios, then DB decisive bridge, DB scan, optics, HDB scans, all are the popular algorithm. Now, when to use which algorithm? So, well separated and globular cluster, partition based, nested or hierarchical relationship means, so that is a hierarchical cluster. Cluster with arbitrary shape or noise, density based. Unknown number of cluster, again density based, and high noise, that is a density based. Applications, core differences, that is a supervised learning, unsupervised learning, and then the thing. So unsupervised learning, again, hidden patterns. They having the k-means, PC and all, and SAPI supervised small label plus large unlabeled data. Improve learning with the minimum labels and the self-learning label. GNNs and the Laplacians are the generative AI, and that SVM are there. Speech recognition, text classification, industry fault detections are the key thing. Now, these are the algorithms. Okay, so here I am stop talking. Lot of talk I had done. If you have any question, any queries, so you can ask. Otherwise, I do having the one of the query or a question for the participant. So if you are learning the machine learning or artificial intelligence or a deep learning, what is your primary assumption of about the data? Which data gives me the better model training or a better model accuracy? Similar data or a dissimilar data? Hello?
Yes, sir. You are audible. Anyone who would like to answer this question?
How one can achieve the best model accuracy with the similarity in a data or dissimilarities in a data? Anyone? See, similarity. What are the logic behind that? Okay, I am giving you the correct thing. See, might be you people heard about the uh, data should be accurate enough that is good one. Similarities again, it is I am giving you the answer. That is a good one. Let's say you all heard about the R square and the R method. R, that is a we having the mean, and then there is a distance, data point distance from your mean, and that is my R square. So if my R square is going to be high and R square is going to be low, that will be affect my model a lot. Okay, that is a one of the key thing one has to be remember all the time. Let's say I am saying the similarity. What is the meaning of similarity? Let's say my datas are similar, and if I am doing with the mean, so all the datas are around the mean. So I do not having any varieties in my data. So my model could be trained is very my model training is, there is no meaning to train my model because everything is around the mean. So there is no requirement of the model. But when I do having the very dissimilar data, or I mean to say that there is a huge variance in my data, that time my model having the variations of the data are available, which help my model to train. And when there is a unfavorable or a unconditional events are occur, or things are occur, or the new data points are occur, it can accurately predict the things. Otherwise, if we are going with the similarity and all the similar things are there, then you should just go with the mean or a median. That will give you the answer. Then we do not require the any kind of machine learning or a supervised unsupervised learning. So I just ask this kind of question to my every PhD students whom I going, what kind of data you can search for. Yes, there is a very good scope in a generative AI and the XAI. Rather, you can see, according to me, as again I am saying, it is my perception and what I read. The scope in a AI and ML in a financial technology is a huge one. Okay, the reason behind that, you having the crypto. Okay, that is blockchain technologies are there, and another thing, the datas are huge, the applications are huge. Similarly, generative AI, the transformer models and the language models are good one, but instead of that, you should focus on a expandable AI, or one of the thing are that the another one is your multimodal AI. So text plus image, text plus audio, or audio plus image, that give you the uh, good research paper publication, even the good things over there. If I am going with the LLM, the lot of resources and the things are required, and that is one of the limitations for the students. Your the basic data availability for the sectors like agriculture, you find out lot many datas, even though हाँ जी sir, even though हाँ, and agriculture, financial, healthcare, you finding out the lot many data. Security, you can work with the security, but data is there. I am not the security person, so I read few papers, but I am not a security person, so uh, I cannot be answer correctly on this question. You can use the AI model or a ML or DL model for the fraud detection, anomaly detections, okay, for your security purpose. That is no doubt in that. Even your blockchain or any other, your IoT and all, you can go with the security, all these things. Yes, yes, you can. You can. Security with AI is possible. That is a good domain, but I am not working in a security domain. So what kind of things I can do with the in a security with ML and DL algorithm, on that I cannot talk more on these things. My basic uh, working of the ML and DL is a financial sector, agriculture sector. I can talk on those one. Even my another one is with the communication. Okay, electronics and communication. So optical communication, where I can use those one, even RF and RF communication, where I can use ML. that are my domain. So I can talk more on this one, but I think it is again not be aligned with the today's scope and the scope of this talk. There are a lot many applications and lot many sectors where students can and the researchers can work. Any other question? Yes, you can. Quality analysis again you can doing on those one. Now over here, what kind of quality you are targeted for, means what quality and which domain you are targeting. Image based means image based you finding out the food quality or something like that. What is your basic question? Okay, yes, you can. That is but it is a very old problem. Your BTech or MTech students can work. Okay, this kind of problem is very, that is a identification of the uh, bad food or a good food, even the adulteration, even though you having the ripen of bananas, fruits and all. That is a very old problem in this domain, ML and DL. Generally, we are not using DL for those one. We are using the ML techniques for those things. Yes, rice, you can. I never come across such problem. You can. You can whatever you having your knowledge, domain knowledge, that is, and then you can apply your based on that data, whatever data you train your model and you can predict. Or generally people are also merge the two things, unsupervised learning and supervised learning. Means they first of all they apply the unsupervised learning and then they apply the supervised learning. That is again be a new trends are there. Any other questions? According to that, we can having the unsupervised, you having the clustering, and then you having the based on the clustering, you can apply that is you based on that you can apply the classification and the regression. Okay. So you having the good rice, bad rice, or your quality of rice based on the that is the size of the rice also. So you cluster, you make a cluster, and then based on that cluster, you again be predict something. Those data are coming, and then you train those data to your algorithm, and you predict. That are the things.
Thank you so much, sir. That was like a very insightful and session, and I hope everyone has enjoyed a lot about it. So your examples and your practical perspectives have not only enriched our learning, but also inspired us to explore more about AI and ML with greater enthusiasm. We are truly grateful for the time and effort you have taken to guide us today. Thanks a lot, and I'm certain that all the participants have gained valuable takeaways from your talk. That was an amazing session. Thank you so much, sir. Thank you.
Thank you so much, and I am very much honored to represent my whatever I learned regarding machine learning and deep learning AI in front of all the my fellow members and represent the RISV Engineering College at ATAL platform. When I thankful to my college also, that is Sarva Janik College of Engineering and Technology, and now we are Autonomous University, Sarva Janik University.
Okay.
So thank you so much. Thank you so
Thank
much
you.
for the organizer and all. Thank you.
Thank you so much for your time, sir. Thank you so much.
Email ID. Okay.
Yeah. Okay. Everyone, let's move on to the second session for the day. Our second session for the day is on machine learning fundamentals, tools for AI/ML, supervised learning algorithms, and linear regression. We are privileged to welcome Dr. Pranav Nerulkar, a distinguished educator, researcher, and AI specialist. He's currently working as a specialist AI and data science at Utkarsh Minds and continues to inspire students as a visiting assistant professor at NMIMS University and SPIT Andheri. Dr. Nerulkar brings with him a rich blend of industry and academic experience. He has worked as an AI engineer at Ignogo, France, and served as a postdoctoral researcher at the University of South Brittany, France. His teaching journey spans reputed institutes including Meritorium Academy and Utkarsh Minds Institute, where he has been mentoring students in data science. A proud alumnus of Sardar Patel Institute of Technology, he went on to earn his ME in Computer Engineering from Thadomal Shahani Engineering College, followed by a PhD in Computer Engineering from VJTI Mumbai. His academic excellence further extended with a postdoctoral fellowship in France. With 34 research publications, 604 citations, an H index of 13 and an I-10 index of 15, Dr. Nerulkar has made significant contributions to the field of computer engineering. His research spans machine learning, deep learning, image processing, hypothesis testing, and prompt engineering. Dr. Nerulkar also holds 62 certifications from Coursera, covering diverse areas such as NLP, machine learning engineering, and even material science. His expertise extends to deploying models, detecting deepfakes, and creating an impactful AI applications. Today, he joins us not only as an expert in artificial intelligence, but also as a passionate educator and researcher dedicated to shaping the future of technology. Over to you, sir.
Thank you, ma'am, for the great introduction, and thank you all of you for joining, and especially prestigious Rizvi College of Engineering for getting this grant from central government and inviting me for this session. So I will share my presentation.
Yes, sir, please.
Let me know if the screen is visible, slideshow is visible or not.
Yes. Yes, sir, it is. It is. It is visible. Your screen is visible.
Okay, perfect. So my topic is machine learning fundamentals, especially the tools that you can use for building applications. Before I begin, can I know how many of you are aware of machine learning? That means you are teaching it, using it, learned it. Can you write in the chat whether you are aware of machine learning, yes, or do you want me to explain from scratch? Okay, I can see a couple of responses. Can I? Okay. Learning phase. Okay. Aware. Even those who are not aware can mention that no or okay, beginner. Basic concepts. Okay. So great. I can see that several have responded. I'm thankful for your response. So my question is, what is the difference between artificial intelligence, machine learning, and deep learning? Can anyone mention in the chat? The difference between artificial intelligence, machine learning, and deep learning. Don't hesitate. You can type in the chat. You can unmute and answer. Okay. We have one response. Deep learning is a subset of machine learning, whereas machine learning is the subset of artificial intelligence. Okay, we have one more response. Machine learning requires less data and deep learning requires larger data sets. Okay. Anyone wants to contribute to our conversation? The difference between artificial intelligence, machine learning, and deep learning. Okay, we have one more response that says we need labeled data in machine learning. One more response is that the layers of deep learning models are more. Okay. Any other responses in 15 seconds before we continue? We have one more response. Multi-layered artificial neural networks learn patterns and make decisions from large data sets. Okay. Any final thoughts? Anyone? Any final words? Don't hesitate. If you are finding it tough to type, you can always unmute and answer. Okay. AI is a broad field creating intelligent machines. ML is the subset of AI. And deep learning is the subset of machine learning that uses complicated deep neural networks for tasks. Okay. So thank you for your contributions. Deep learning is the subset of machine learning using neural network. Thank you. Thank you so much for contributing. So my visualization on the screen, hope everyone can see that AI is a broad field where machine learning is the subset and deep learning is the subset of machine learning. We are going to discuss about machine learning specifically, a popular branch of AI focusing especially on learning without being explicitly trained. That is learning from data itself without any explicit programming. So how machine learning works? Again, those who are aware can guide us in this. So let us say I want to build a house price prediction system. So on what basis will I predict the price of a house? Okay. Can anyone contribute? On what basis can we predict the price of a flat in Mumbai? Don't hesitate. Think on this. Suppose you want to decide the price of a house, price of a flat. We will narrow our scope. In Mumbai city. So on what basis will you estimate this price? We have multiple responses. I am thankful to the audience for being so prompt. We have from experience, one answer, size, room, flat size, location, area, square feet area, location, shape, location, floor, amenities, size, floor number. Okay, one answer is that from linear regression. Okay, from location, amenities. Okay, whether it is situated in Andheri, Bandra, or Kandivali. Okay, so many answers. In short, you will predict the price of a flat on the basis of the features of that flat. Okay, these features are the location, the area, the floor number, the developer reputation, the time at which the flat was constructed. So multiple features will decide the price of a flat. Okay. And now let me ask another question. Suppose there is a photo. On what basis can I say that in that photo there is a how do I recognize whether that photo is a photo of a cat or a photo of a dog? How can I recognize that? I have on the screen also one photo. So how will I say that this is a photo of a cat or this is a photo of a dog? On what basis will I decide? Okay, physical features like body structure, face. Okay. So now tell me that your camera, on what basis does the digital system recognize a cat or a dog? How can a digital device like a camera, a computer recognize whether that image is a cat or a dog? Okay, so some answers we have: patterns, maybe AI. So we have features, saved patterns. So this is good. So that is the difference between machine learning and deep learning. In machine learning, we work on features. When I asked you, how do you recognize the price of a flat? You gave me multiple features. When I asked you, how do we recognize the photo? You gave me multiple features like shape, body. So this learning from features and making a prediction, that is machine learning. Now, what is deep learning? What do you feel? Any answers? What is the difference between machine learning and deep learning? What can be the answer? The difference between machine learning and deep learning. Okay, we have that deep learning is a subset of machine learning. Okay, deep learning is using the neural networks. It is capable of identifying a cat. Okay, the data handling features are learned automatically. Okay, anyone else wants to answer? The difference between machine learning and deep learning. Okay, so The difference, as many have pointed out in the chat, is that machine learning requires features, handcrafted features. That is, features that are decided by humans or experts. So we call them handcrafted features. In deep learning, we don't depend on handcrafted features. We learn the features from data itself. So when you practice, you will not, in deep learning, you will not be required to extract features. The AI model itself will extract features. These are called as data-driven features. Whereas in machine learning, the human expert is deciding the features. So those are called as handcrafted features. So multiple applications of machine learning, deep learning exist. We are here to discuss some tools and some applications. So can you give me any application of machine learning or deep learning or AI in the chat? Something that you have used, something that you have learned, heard, seen, applications of machine learning, AI, deep learning. Can you put in the chat? Even if you are unsure, you can answer. We have spam detection, we have voice assistant, we have recommendation systems. I'm only getting answers from these same people, just like in a classroom, how the front benchers are answering all questions. So I hope to get some new responses. We are more than a century, audience is more than 100. Come on, participate, answer in the chat. Applications, softwares, tools of AI, machine learning, deep learning. Okay, we have computer vision, we have natural language processing, medical diagnostics, smart assistants, disease prediction, automations, recommendation systems, voice assistant, spam detection, even large language models, Siri, NLP, Python, Google Assistant, automation, NLP. Okay. So in short, applications that predict, that estimate, and even generate. So multiple applications are there. You have mentioned them. We have experienced some of them. We have experienced the effects of some of them, especially e-commerce recommendation systems, spam detectors. We are experiencing the effect of these systems because we all use mobiles, we all use websites, we are on multiple apps. So we have experienced the effects of these AI systems. Everything is getting tracked. Everything is getting monitored. AI and God are seeing everything. They are present everywhere. So multiple applications everyone has given in the chat. I also have collected few for you, like even navigations, like self-driving cars, process optimizations, stock market analysis. We have customer retention, image detections, fraud detection, visualizations, targeted marketing like ads, games, real-time decision making, multiple business related applications which we are experiencing. So machine learning applications, we can categorize them into multiple groups. Let us take one categorization which is very common based on the nature of data as supervised and unsupervised. What is the difference in these two groups? Can anyone give in the chat or unmute and answer the difference between a supervised learning machine learning application and a unsupervised learning application? Okay, we have one answer, labeling of data. Anyone else? Okay, so supervised learning uses labeled data, whereas unsupervised learning uses unlabeled data. Okay. Any other answers? Okay. Input and output is known in advance in supervised learning. Okay. Okay. So known answers. Learn from labeled data. Okay. Good. Good. Thank you. Thank you for your responses. Even on the screen, we have illustrated the difference, that one is where in supervised learning we explicitly have a labeling or labeling entity called supervisor that is telling that this data is apple, this data is mango, this data is pear. So that is why the model is now targeting to identify from the image what kind of fruit. So it clearly knows that the apple is, it has a large amount of labeled data of each type of fruit, of the three fruits. Whereas in unsupervised learning, there is no labels. Just we are giving the fruits and the algorithm is deciding that, okay, if I want to group this, I can group it on basis of shape, I can group it on basis of color, I can group it on basis of taste. There are many ways I can group this. There is no fixed groups. Grouping is subjective. There is no correct answer. Multiple correct answers exist. There is no fixed correct answer. So in unsupervised learning, we allow the algorithm to decide on what basis it wants to group the data. It may not always be that we may get exactly 3 groups for the 3 fruits. We may get maybe 2, maybe 5. The groups may be on basis of color, taste, size. Many ways of grouping are there. So each of these has multiple applications. For now, let us concentrate on supervised learning. In supervised learning, the two popular applications are regression and classification. So what is the classification and what is regression? Regression outputs numbers, classification outputs categories. So anyone else? Regression outputs continuous values. Any example of regression and example of classification? Okay, classification outputs discrete values, regression outputs numeric values, continuous values. So any example of applications for classification or regression? House prices, yes, house price prediction, forecasting the temperature, determining if email is spam or not will be classification, predicting continuous values, predicting gender, customer sentiment analysis, multiple applications you have contributed. Others also can contribute. Understand the difference between classification, that we are predicting discrete classes. In the image, it is given that will it be cold or hot? So it can either be cold or hot. Okay, so this is a prediction of limited categories. One of the category will be the answer. Whereas what is the temperature going to be tomorrow? So here there are infinite categories because the temperature is a number and numbers can have infinite possibilities. It is a continuous prediction, whereas classification is a discrete prediction. So multiple answers are there. I mean, if you go through the spectrum of answers, you may get many project ideas. So good. Uh, I recommend that those who are new to machine learning, they can see especially the project ideas given in the chat from different domains. Very interesting ideas. So I spoke about house price prediction. Now the data. So for machine learning, let us say you want to build a machine learning AI application or a deep learning application. So what kind of data will you require? Can you give some examples of applications and the data required to build those applications? Okay, say you are building a machine learning application or deep learning application or AI application. So what kind of data will you require? What kind of data will you collect? Okay, image data, text data, audio data. Any examples? Any other examples you want to share? Everyone, what kind of data will be required if you want to build a machine learning, deep learning AI application? Okay, audio, text, image, customer data of bank, structured data, semi-structured data. Okay, multiple. Anyone else? What kind of data will be required? Those who have some experience, what kind of data did you use in machine learning, AI applications that if you have built? Okay. Okay, hybrid data, training data, validation data, stock market data, label data, structured, semi-structured, unstructured data, audio, image, and text. Any other answers? Time series data. Categorical structured data, okay. Multiple answers are there, multiple answers. So the data that everyone has suggested, it is of two categories or three categories. One is the structured data, other is the unstructured data. The structured data and unstructured data, what do you feel is the difference between these two types of data? What is the difference between structured data and unstructured? Okay, so one is saying unstructured data. Data, okay, organized. So you can see that structured data is in tabular format, whereas unstructured data is not in the form of tables. It is image, audio, text, video, PDF, many forms. So in this, you will find that majority of machine learning applications, they depend on structured data. Because you can, if you are having handcrafted features, in that case, your data is likely to be tabular, likely to have the structured form. If you are working on deep learning applications, your data is likely to be unstructured, because deep learning applications don't require you to have handcrafted features. Okay, so especially it is challenging to get features from audio, images, text, videos. So that can be one point of distinguishing between a machine learning and a deep learning application. So you have a large amount of unstructured data. A very minor component is the structured data. Here some examples are compiled. It is the unstructured data is something that humans interact with on day-to-day basis, like image, video, audio. They are exposed to unstructured data, humans. So that is the reason why deep learning focuses on unstructured data, and majority of the deep learning applications are competing to achieve human level accuracy. They are applications that like they are trying to imitate humans, like being able to see image classification, being able to understand audio, video. So they are all focusing on unstructured data, deep learning applications. Machine learning applications are focusing on structured data. Then there is a semi-structured, just for information, which is not completely structured like a table, but not completely unstructured like text. It is between the two. That means it has labels, tags to identify the components of data. Now, our main discussion is the machine learning techniques, machine learning algorithms. There can be two families of machine learning algorithms. The simple ones are the linear ones. The complex ones are the non-linear. And today we will see one example of a linear technique, how it works, called ordinary least square or linear regression. Before we dive into the maths, let us say that I'm building a machine learning application. In this machine learning application, I'm trying to predict the price of the flat based on the size. Size is the only feature for now. Price is the prediction based on size. And let us say that my data looks something like this. That when the size is 10, the price is 10. Size is 20, the price is 20. When the size is 30, the price is 30. So what will be the price when the size is 40? In this question, we have to predict the price based on the size. And the size is given as 10 and the price is also 10. When the size is 20, the price is 20. When the size is 30, the price is 30. So what will be the price when the size is 40? You can give your answer in the chat. What will be the price when the size is 40? Okay, we have some answers. So when the size is 40, you are saying the price will be 40. Why did you say that? Means what was the relationship between size and price that you understood? Okay, linear fashion, linear model. Okay. So how did you understand that the price is 40? Okay, if you change an input, the output changes in the constant proportion. So I had given in the question that when the size is 10, the price is 10. When the size is 20, the price is 20. When the size is 30, the price is 30. So this was what we call as the training data in any AI, machine learning, deep learning application. Now, these values that I gave you, you were training on those values. Once you got trained, once you understood this relationship that the size and price, they have a relation. In that case, you were able to easily answer that when the size is 40, the price will be 40. The relationship that you mentally calculated was that the price is equal to the size. That means the price is having a linear relationship with the size. And it is this linear relationship that is calculated by the linear regression AI technique, machine learning technique. Let us say that if I plot, if I have a graph of, on x-axis I have the size, on y-axis I have the price, and I plot the points that I told you. When size is 10, price is 10. That will be the first point. When size is 20, price is 20. That is my second point. When the size is 30, the price is 30. That is my third point. So if I draw my graph, so here is my size, here is my price. These are my 3 points. So the relationship between size and price is this line passing through the center. And then when I asked you when size is 40, what is the price? So all you did was, once you have learned the relationship, that is when you got this line, you can easily plot. So you have learned the trend from the data. So if unknown data, unseen data out of sample data is given to you, you can predict based on the previous historical training data. So that is the way a machine learning model we build. We keep a subset of data for training, we keep a subset of data for testing, and we keep a subset of data for validation also. So on training, once the model has learned a relationship between input and output, then on the testing, we can evaluate the results and understand whether the model is accurate or not. The linear model, the linear regression, is working the same way. X is the feature. Let X be the size. Let us say X is the size of the flat or the apartment. Then we have Y. Y will be my price. Okay. And we are just plotting this training data here. These blue dots are the training data. And I'm trying to learn the line, the equation of a line, which is y is equal to ax plus b, where a is the intercept and b is the slope. So I'm trying to learn a and b, which is the slope and intercept, which will give me this line, which will ideally pass through all the points. That way, if some unknown size is given to me, I just have to touch it on the line and I can make my prediction. So if some unknown test data is given to me, I will call it xt or xtest. So I can just, I have my line already from the training data and I can see where y will be, and that will be my prediction. Any questions? Don't hesitate to have any questions. So if you want to apply linear regression, what you will need is a data set. You will need some understanding of programming languages, any programming language. Say, if the programming language you choose is Python, then in that case, you will need to use a Python library. One suitable library is scikit-learn, other is stats models. Many libraries are available on which you can develop the linear regression model. On some kind of data, linear regression will work very well. Data which in which the relationship between input and output is linear, where there is no correlation between the features, where the features are normally distributed. So under such assumptions, you will find that linear regression is able to learn the pattern in the data. So what will be the steps? Although there are many steps while applying linear regression, I have illustrated them. First, then you can at your own pace go through this flow chart. It looks a bit complicated, but it is just giving you the sequence of steps that you have to follow while building any machine learning model. Any term in this flowchart that is new for you requires some explanation. Don't hesitate to mention in the chat if there is any term given in the flowchart that is new for you and requires elaboration. Hyperparameters, okay. Okay, so understood. Read this flowchart and see if any term is there that is new for you. Okay, so the steps are not specific to linear regression. You can use them for applying any machine learning model. The general steps are that first we decide whether our task is supervised learning or unsupervised learning. If it is supervised, then is it regression or classification? Then we start to collect the features and the target. If our task is regression, then we choose to begin with linear regression. So we need our data in the form of table. We separate out X and Y. We break our data into train and test, two sets. Then we bring all the features of X in a small range that is called as standardization. Next, we have to try different combinations. Any machine learning model, if you are using machine learning model, then think of it as a FM radio. You know, you have many buttons on the FM radio. You have to find the correct frequency. So you have to turn many buttons. Okay, turn this, turn that, press this, press that. Try which combination is giving you the, at which combination you are finding the ideal frequency. So that process of trying the different settings and finding the correct setting of a machine learning model is called as hyperparameter tuning. So we find the right settings for a machine learning model using hyperparameter tuning. It is easy to do this because now so many automated tools are available. Once our model is optimized on the training set, then we apply it on the test set. Okay, so that think of it as taking an exam of that model. Training is like you are teaching that model, and once you are done teaching, you have to take an exam of the model, and the machine learning model will give some correct answers, wrong answers. So you will say that you will give a marks. Okay, this model has got 90% marks, 80% marks. On the basis of those marks, you decide whether you want to retrain the model or you want to maybe teach the model more. That means collect more data and train the model, or try a different model altogether. So it is quite a extensive strategy. It is definitely the challenging part. Speak with any machine learning enthusiast, and that person will tell you that the most time consuming portion of this flowchart, what do you feel is the most time consuming portion of this flowchart? What do you feel? Which step takes the most time in this flowchart? Okay, we have one answer, data collection. Any other suggestions? Hyperparameter tuning. Okay. Anyone else would like to contribute? Which will be the most time consuming step of our process of machine learning? Okay. Training. Okay. Pre-processing. Perfect. So definitely data collection, pre-processing takes a long time compared to the actual task of training and tuning the model. So, but these days there are many data sets readily available. Where would you find, can you name some good sources of data sets which you can use for AI, machine learning, deep learning? One answer we have got is Kaggle. Yes, kaggle.com. Definitely one good source. Hugging Face is also one good source. Many data sets you will get, both structured, unstructured. Any other good sources of data sets? Government of India website. Okay, GitHub. Multiple sources of data are mentioned. KD Nuggets is also one website. UCI ML repository is also one good website. TensorFlow datasets. So these websites you can explore for the data. Then there are many tutorials available on kaggle.com, KD Nuggets. Geeks for Geeks has many tutorials. GitHub will have many tutorials. YouTube has many tutorials. So those who are starting, then definitely these resources are good place for beginning. There is a Coursera course by Andrew Ng on machine learning, but that is not in Python, that is in Octave, but a very useful course. That is a very good point, starting point for those interested in beginning machine learning. Coursera course from Andrew Ng, Introduction to Machine Learning. Even on YouTube, we have Krish Naik. Krish Naik has good tutorials. So I think we are out of time. Do we have time, or I think 9 was the stopping point, or was it 9:30?
So since today is the first day, it's going to be until 9:30.
Oh, okay.
Yeah.
So one website one resource which you can explore is YouTube, Krish Naik and Andrew Ng. Then if you are interested in deep learning, then Intro to Deep Learning. This is also a good resource. Then okay, so can we see one basic data set from Kaggle and how to use it? Definitely, we can see that. Maybe you will not be able to follow it, perform it with me, but you can just see it and later on you can perform. One good resource where you can practice Python programming and is this website collab.research.google.com. So on this website, you can sign in using your Gmail account. Multiple. So what is the use or benefit of this website? One benefit is that you don't have to install Python. You don't have to install any softwares. You just need an internet connection. And that's it. With that limited information, you can start. So let us see one simple example of how linear regression can work in practice. Those who are not comfortable with programming can also use softwares like ChatGPT to generate their code. So I have this tutorial exercise day 2 page 1. So this is on linear regression. First, we require in Colab, we don't have to install anything. There is code cell. We can write our programs in the code cell. We can execute them by clicking on this button. Here I will need some libraries of Python. One is the NumPy library, the Pandas library, and the sklearn. That is the scikit-learn library from machine learning, from Python. Scikit-learn library has the linear regression class, which is implementing the linear regression. So you don't have to build the linear regression from scratch. You can directly use it on your dataset. So not from Kaggle, but sklearn itself has a diabetes dataset. So let us see on this diabetes dataset. The dataset is already in a structured form. So we have loaded the dataset into two variables, X and Y. How is the dataset looking like? It is having 10 features and Y is the level of diabetes. So it is a regression problem because you can see we have to predict the level of diabetes on basis of these 10 features. Let us tell you also what are these 10 features. These 10 features are age, sex, BMI, blood pressure, and some body features which are hidden to protect the privacy of the patient. They are encoded as S1 to S6. For more information about this dataset, you can always search the sklearn diabetes dataset. Here we have the diabetes dataset information. There are information of 442 patients. The meaning of each features is given in the user guide. So let us check what is the meaning of the features. So here it is total serum cholesterol, low density lipoproteins, high density lipoproteins, total cholesterol, blood sugar level, possibly log of serum triglycerides level, age in years, sex, body mass index, and average blood pressure. A study done by this institute in 2004, published on these two websites. So we have this, then the prediction is the measure of diabetes. So we have these 10 features. So one advantage is there are no missing values, there are no duplicates, there are no illegal characters. All the features are already cleaned, pre-processed, everything is done for us. If you see the plot of the features, then you will find that more or less all the features are in the uniform range and centered at 0, and range is very small, which is perfect, ideal for machine learning, that all the features should be in the same range, which is the case of this data set. Otherwise, you will have to use standard scaler to bring the data in the same range. Now I am splitting the data set as train and test. Usually we keep 80-20 as the ratio, 80% in training, 20% as the test set. So that is done. Now I initialize my linear regression model. Here I did not do any hyperparameter tuning. Let us just use the baseline model, fit it on the training data, predict on the test data, and check the error. So there is 40% error. That means the predictions are off by 40%, which is a very poor model. So one way to improve this is by applying hyperparameter tuning. That is by changing the hyperparameters of the model. Now I will just write hyperparameter tuning of OLS using grid search. So grid search, and ideally it should give me the code, or I will just use this AI feature and write give code. So it will give me the code, then I will just use the code and see the result. AI will simplify the task of coding. Now here we have got the grid search. So one hyperparameter of the linear regression model is the fit intercept, where will we get all the other hyperparameters. So you can go to the website of linear regression, sklearn, and on this website you will get the different hyperparameters of sklearn. Multiple hyperparameters are there. One is fit intercept, the other is tolerance, the third is positive. So three different hyperparameters are there which we need to tune. So we will just modify our code and say that tune also the all hyperparameters like tall and positive. Let AI do the work. We will just check our results. So it is doing, we accept. So in short, all these combinations will be tried and the best model will be finalized. Something went wrong. Okay, so there is no tall parameter. So we remove that. Okay, so we have applied the hyperparameters. This is the best set of hyperparameters. That best set we save in a variable. So get best set, get best model on grid search. That's the best model. This best model we apply on our this best model we predict on our test set and we check. So there is no improvement of error. It is still 40%. Sometimes the model is not good enough because the data is complex. There is a non-linear relationship, and linear regression is too simple to learn this non-linear relationship. Remember that every AI model has some shortcoming. So we will have to change the AI model and use some non-linear AI model here, and maybe that will improve our performance. So this was the code that you can use for trying the this you can use for testing your AI model. There is another library, stats models. You can use that library as well. So in that library, again is it is a good library. It will give you multiple performance measures. So here also we can see that the R squared, which is a ratio of, which is a measure of quality, that is 0.51 when it should be close to 1. So linear regression is not a suitable model for this kind of data. This is how we have applied linear regression. Here, the painful part like data collection, feature handcrafting, that we avoided. We did not do that because we got a very clean and proper data set, which saved us time so that we could just focus on the linear regression modeling. Any other suggestions? Anything else that you want to know? We have 5 minutes left. Anything? Any suggestions? Any topic that you want to discuss? Any obstacle you are facing and you want suggestions? Email ID, I can put in the chat. Some questions we have got. What ML algorithms are best suited for predicting pesticide levels in food? Difficult to predict because multiple factors are there. What is the format of data? What is the relationship between input and output features? What is the quantity of data? In that case, I will suggest that you try multiple linear models, you try then non-linear models, and on the basis of accuracy, you can decide. Basis of the test set accuracy, we can decide the performance. Okay. If you want the PPT, I will give in the chat. If you want this code, then also I have given in the chat, or I can share it with the organizers. Okay. Yes, the program I have given in the chat. The steps are there in the presentation, which also I have given in the chat. Then some are asking for attendance link. which the organizers will share. Tools for machine learning are those who are using R programming, and they have Caret, C-A-R-E-T, Caret library of R, very popular, multiple machine learning models. In Python, you can have the scikit-learn library. If you are falling short of data, then you can collect additional data, or if data augmentation or generative AI you don't want, then you can collect additional data. Okay, so thank you to all of you actually for being so responsive, being so participating so much, being so enthusiastic, responding in the chat with your ideas, with your thoughts, which made this a very energy-filled session. So good. Thank you, everyone. That's it from my side. Have a good evening. I hand over the session to our organizers.
Thank you so much, sir. Thank you, Mr. Nerulkar, for sharing your valuable insight with us and for delivering such an engaging session, sir. I also thank all the participants for being an amazing crowd. I will share the feedback and the attendance link. I would request everyone to fill in. Just give me a second.
Ma'am, we would like to take a photo.
Sure, yes, sir. Yes. In that case, while filling the form, I request all the participants and the speakers for the day, the dignitaries on call to come on camera for a quick picture. I also request our Dean Academics, Professor Shiburat sir, to lead us ahead with few other instructions.
Okay, hello everyone. I request everyone to turn on their camera so that we can take a photograph. Shahjan ma'am can take the picture. Okay, few instructions from our side. After every session, there will be a feedback form. Everybody should fill that. That is the attendance come feedback form. Also, at the end of the 6-day FDP, you will have to be submitting a report on the whatever you have learned in the 6-day FDP. So the format will be shared with you, and also there will be a test based on all the sessions, and as per ATAL, 70% minimum marks are required to get the certificate. So at the end, based on every session, there will be few questions, and that exam needs to be cleared to get the certificate. Okay, I hope the things are clear. Over to you, ma'am.
Thank you so much, sir. I would take a minute to thank our speaker. On behalf of everyone present, I would like to once again extend a heartfelt gratitude to Mr. Nerulkar. Your thoughtful responses to our queries not only clarified our doubts, but also provided us with deeper perspectives on the subject. The patience and clarity with which you addressed each question reflect your generosity in sharing knowledge and experience, sir. We truly value the time and effort you have taken to guide us today. We look forward to carrying these insights in our future interviews. Thank you so much, sir. Thank you for your presence today.
Thank you, everyone.
With this, let's look into the summary for today. Today, the sessions by Professor Lapsiwala and Mr. Nerulkar, we gained valuable insights into fundamentals of AI/ML, unsupervised learning, clustering, supervised algorithm, including linear regression. With this, we conclude day 1 of ATAL FDP. On behalf of RSV College of Engineering, Computer Department, I sincerely thank our speakers for sharing their expertise, the participant for their active presence, and organizing committee for their tireless effort. We are grateful to our principal, Madam Dr. Varsha Shah, management of RCOE, and to AICT for constant support in making this a reality. We look forward to your participation for day 2 tomorrow of the FDP. Thank you, everyone. You have a good evening. I request all the participants to fill in the form, both the feedback form, that is 1 and 2, before leaving the meet. Thank you so much, everyone.